So this time you have completed a lot of problems involving recursive formulas and trying to match graphs. So keep in mind we have three possibilities. So arithmetic, what operation do we see when writing the recursive formula for arithmetic? Geometric, again, what operation? And then our newest one, shifted geometric. Again, we're looking at the recursive formula, what kind of operation or operations will we see. And then in terms of the graphs, there's two of them are geometric, one of them is arithmetic. So what kind of shapes are we looking at? So think about the question, have a conversation with your partner or someone sitting next to you. And then when you're ready to, when you selected your answers, turn the video back on and we'll check the answers. So geometrics are always multiplication, arithmetics are always addition, and shifted always have a combination of multiplication and addition. Keep in mind that you might see a subtraction problem instead of addition. Your textbook is kind of inconsistent with the rule here, so just understand that if it says subtract 3, that's the same thing as adding -3. So for the problem A, it's an addition problem, so that means we're looking for a graph is going to be an arithmetic. Arithmetics are linear in shape. Here we have a multiplication problem. So that tells me, and it's just multiplication, that tells me it's geometric. And the graph is going to be nonlinear. And then the last one, we have multiplication and addition. And this is a shifted geometric. And it's also another nonlinear. So anytime you see the word geometric, whether it's geometric or shifted geometric, you should be thinking nonlinear. So letter A is an arithmetic linear. That means the third problem is the graph that would go with the arithmetic sequence. For geometric and for shifted, keep in mind that the graphs themselves for shifted will either go up like this or they're coming down. So they're both coming down, whether they're starting that way and going up or starting very high in terms of the negative side coming down. But they're both at some point, at some place along the answers, they're approaching 0. Shifted geometric is kind of leveling off. It's called a long run value, but generally it's never the x-axis, it's somewhere else. So this graph, number 2 here, if I would continue to extend the graph to the left, it's approaching the y-axis, or they're called n here in this problem, but it's approaching that axis. This is a geometric. And the other graph seems to be, the points seem to be closer and closer together, which means it's leveling off somewhere in here. That's called the long run value. And that's the shifted geometric. So look for curved graphs that seem to be leveling off somewhere other than the x-axis. In the next set of problems, we're looking at long run value problems. So kind of a reminder about long run value problems. Whenever I have a shifted geometric, so again, we do long run value problems on shifted geometric sequences. What we need to understand is that as the graph, let's say it starts here at 20, the points are further apart, and then as the graph begins to get closer and closer to that long run value, the points get closer and closer together. And if I go far enough out, eventually the points would be so close together that we probably couldn't even tell the difference on a calculator when trying to calculate the answers. So what I need you to understand is that for a long run value, if if I go out far enough, let's say, X is 1,000, or X is 10,000, or X is 1,000,000, and then 1,000,001 for X, those answers are going to be so close that we're not going to be able to see a difference in the answer on the calculator. So what we're going to do is we're going to let the U of n and the U of n minus 1, we're going to let those two things equal each other when looking for a long run value, because as I go out where X is extremely large, the difference in the answers is so small, you're not going to see that difference in your calculator. So I'm going to do the first one for you, and then I'd like you to attempt B and C. So you take U of n equals 1 minus 3/10 U of n minus 1 plus 10. So the first thing we need to do is simplify this parenthesis, which becomes 0.7. So I'm taking $1, taking away 30 cents. So I got 70 cents left. Times U of n minus 1 plus 10. This is where we're going to let the U of n and U of n minus 1 equal the same thing by taking these two things here and replacing it with the letter C. Now, why C? That's the letter your textbook uses. I mean, could we use other letters? I would suggest using C, but as long as we're not using R and D, because we're already using R and D, you could probably use some other letters you like. And then we're going to solve this equation. So this is where we're going to stop for a moment. I'd like you to solve the rest of this equation for C. And let's see if we can determine the answer. And when you're finished, check with your partner, turn the video back on. So hopefully the first thing you did was subtract 7/10 C from both sides, because you want to get the C's isolated to one side of the equation. So you have 1 C, take away 7/10 C, so hopefully you have here 3/10 C equals 10 on the right side. Got a multiplication problem with 3/10. We're going to divide both sides by 3/10 to create a value of 1 here. So C is equal to 33.3 repeating. You may have approximated this. If you do like to approximate it, which is I'm okay with, I'd recommend going to thousandths, which is 3 digits after the decimal point. If you go ahead and do the other 2, and then turn the video back on when you are finished. So the only difference between A, B, and C is the last number. You look at all 3 problems, they all start at 50. They all 3 have 1 minus 3/10 or 3/100. So the steps really are very similar. And so what I'm going to do is I'm going to place the 20 and the 30 at the end with the letter D, D for difference. And so the first step here, we're going to get rid of the U of n. Subtract that 1 minus 3/10, and then U of n minus 1 becomes C as well. So the problem is going to look like this. C equals 7/10 C plus D. So it's going to look a lot like this problem here, except the difference is going to be, as well as here, is that I want to use D for 10, for 20, and for 30. We're going to subtract 7/10 from both sides. And 7/10 C to get a 0 here. So 1 minus 7/10 is 3/10 C equals D. And like we did down here, we're going to divide both sides by 3/10, which gives me a value of C is equal to D divided by 3/10. So in problem B up there, the answer is going to be 20 divided by 3/10. So hopefully for problem B, you got 66.6 repeating. And for the third problem, it's going to be 30 for D divided by 3/10. So that answer is exactly 100. So we could actually, since the problem is the same problem, we could actually replace the number at the end, the D value, with the letter D, and just write a general equation that will work for any problem that looks like this. And so it would be C is equal to D divided by 0.3. So before we go on to the next problem, what I'd like you to do, actually, the next problem is, I'd like you to sketch the graph for A, B, and C. I know it doesn't ask for that, but I think it's really important that you practice that skill. So if you would please sketch the graph, again, for A, B, and C. When you're finished, turn the video back on. So for shifted, we know for problem A that the long run value is going to be 33.3 repeating. That's the answer we got down here. And the problem is beginning at 50 in problem A. So that means that we're starting at 50, the answers are decreasing and leveling off there at the long run value of 33.3 repeating. So this would be the graph for A. For B, the long run value is 66.6 repeating. Again, the problem is beginning at 50 because U of 0 is still 50. This time the graph's going up and leveling off just below 66.6 repeating. And then for the last one, this would be a good time, if you got the first two wrong, why don't you go ahead and correct the third one. Turn the video back on when you're finished. So the last one, the long run value is 100. It says that, again, we're starting at 50. So U of 0 is 50. So that means the graph is coming up, and leveling off at about 50. Keep in mind that for the long run value, that means that the answer is approaching that number, but it will never equal 100. Problem B, it will never equal 66 2/3. And letter A, it'll never equal 33 1/3. The lesson 1.5 we will pick up with on our next class period.